Determine whether each function is even, odd, or neither. Now, before we do A through D, let's review the definitions of even and odd functions. Remember, a function is even if for every x in the domain, f of x is equal to f of negative x. For odd functions, a function f is odd if for every x in the domain, negative f of x is equal to f of negative x. So what we're going to do is we're going to see if each of our functions satisfies either one of these equations. Let's start with part A. All right, so let's write down our two equations. The function is even if f of x is equal to f of negative x, so we'll check that. The function is odd if negative f of x is equal to f of negative x. So let's first find f of negative x. Well, to find f of negative x, we simply substitute a negative x into our function. We get the negative x quantity cubed plus negative x, and we can simplify. When we cube a negative, that becomes negative, and we're left with negative x cubed minus x. Now let's check to see if the first one is satisfied. So, question, does f of x equal f of negative x? Well, f of x is x cubed plus x, and that does not equal negative x cubed minus x. So it's not even. Let's ask another question. Does negative f of x equal f of negative x? Well, negative f of x, if we multiply our function by a negative, we get negative x cubed minus x. Does that equal f of negative x? Yes, it does. So this function satisfies our second equation, therefore it's odd. Okay? We'll do the same thing for B through D. Okay, let's do part B. Let's find g of negative x first. Substituting a negative x into our function. Okay, and simplify. When we square the negative, it becomes a positive, so we get x squared in the denominator plus 7 times, well, we can rewrite the absolute value of negative x as the absolute value of negative 1 times x, which we could rewrite as the absolute value of negative 1 times the absolute value of x. And the absolute value of negative 1 is 1, so we could rewrite as 1 over x squared plus 7, remember the absolute value of negative 1 is positive 1, times the absolute value of x. Now notice, this is g of negative x, which is precisely g of x. So g of x is equal to g of negative x. That means our function for part B is an even function. Okay, let's do part C. Again, let's start by evaluating, in this case, h of negative x. Substituting that in. And we'll simplify. So we get 2 times. When we take the fifth power of a negative, it becomes negative. So I'll pull that out. And we're left with negative 2x to the fifth. Negative times negative is a positive. All right, so let's check our two equations. Let's look at the first one. Let's see if we have an even function. Does h of x equal h of negative x? Well, h of x is 2x fifth minus 1 over x. That does not equal h of negative x, so it's not even. Let's check our second equation to see if it's odd. Does negative h of x equal h of negative x? Well, negative h of x is negative 2x to the fifth plus 1 over x. Does that equal h of negative x? And it does. So our second equation is satisfied. Therefore, h is an odd function. And finally, we'll do part D. So again, let's start. by this time evaluating big G of negative x, substituting negative x into our function, and then we'll simplify. This gives us x squared minus 4x. Now let's check the two equations. So let's ask ourselves, does g of x equal g of negative x? Take a look. Does g of x equal g of negative x? And that is no. The function is not even. We'll ask another question. Does negative g of x equal g of negative x? Well, let's see. Negative g of x would be negative x squared minus 4x. Does that equal, it's the question, does that equal g of negative x? And no. So this function is neither even nor odd.